Hi, my name is Cassandra Champagne, and I'm a PhD student here at the University of Michigan. Today we are going to be running some permeability tests. And we're going to start with the constant head permeability test, and we're going to go over the equipment to begin with. Always want to have our safety glasses on first, and I'm going to be following along with the lab manual, and I encourage you to do the same. So the equipment that we're going to need, the most important piece of equipment is our permeameter itself. So this is our permeameter set up for the constant head test specifically. We have our soil specimen already prepared inside the permeameter for us. The specimen that we're using for this test is a bit of a coarser material, which is typically what you'll run with a constant head test, as opposed to a finer material with the falling head test, which we'll get to after. Our soil specimen is bounded on the top and bottom by two porous stones, and then in between each porous stone and the soil sample, you see these little pieces of filter paper as well. We have this tube coming in the top of our permeameter, and this is the water inlet. This valve is going to control the inflow, and water will flow in through the top of the permeameter and percolate through our soil sample, and then water will come out here, and this outflow tube is controlled by this valve over here. We also have an additional valve on the top here that we'll be using to get out any air bubbles that exist in our soil sample. That way we can make sure that we're achieving 100% soil saturation throughout the test. Some additional materials that we're going to need for this test include a graduated cylinder, a stopwatch, and a thermometer. And now we're ready to start the constant head test. Okay, so now we're going to look at the entire constant head permeability test setup. The driving principle behind this test is that we need to maintain a constant head differential between where the water is going to come out of our permeameter and the highest elevation of water in our test, which for us is going to be this black line indicated here on the funnel. So we're going to first start by filling up the funnel with water from the faucet. We have an inlet tube here connected to the spout of the faucet that's going to feed water all the way up to the top of the funnel. And so water is going to start pouring in, and then once the water level rises to the black line indicated here, there's an overflow tube, which is a little bit hidden in the back, but it's this tube here where water is going to overflow out of the funnel and get deposited here in the sink. So this overflow tube is the way that we're going to maintain a constant level of water at that black Sharpie line. Then once we're ready to start the test, after we've achieved steady state with the water level in the funnel, we are going to open the valves of our permeameter, and water is going to begin to flow out of the bottom of the funnel through this tube here and into the top of our permeameter. And then ultimately water that percolates through the permeameter will come out of this tube here. And that's basically an overview of how this works. Okay, so we have turned the faucet on to allow water to flow up into the funnel, and we have achieved steady state through the constant head setup. The two ways that we need to check to make sure that this is the case is that we have pretty constant flow coming out of our overflow tube, and I can also tell you that the water level in the funnel is being maintained at that black line. And again, this is critical because for the constant head test, we really need to make sure that we are maintaining that constant head differential. And the constant head differential is defined as the difference between the highest water elevation, which again is that black line on the funnel, and the lowest water elevation, which in our case is going to be the elevation of where the water is going to be coming out of this outlet tube. In our case, we are going to have the tube sitting on this counter when we're actually running the test. So we're going to use the elevation of the counter to the elevation of that black line on the funnel as the head differential. We've already measured this off camera, and we're going to provide that to you. So the next step is now going to be to open the valve on the inflow side of the permeameter to allow water to start flowing through the permeameter itself. So we're going to go ahead and do that. And then we're going to open this valve to get the air bubbles out. There we go. And now we'll open the downstream valve, and we're going to start to see water flowing out of this tube. However, we stopped seeing water flowing out of our overflow tube, which means that the water in the funnel has dropped, basically because we've opened an additional channel for the water to flow out of. So we're going to increase the water level ever so slowly until we see water flowing out of our overflow tube again. The reason we want to do this very slowly is because if we do it too quickly, we can actually fill up the funnel quicker than the overflow tube can get water out, and then the funnel will start to overtop. And then even though we'll have water flowing out of this tube, we won't actually be at steady state because the water level won't be at that black line, which we've already measured to be our constant head differential. Okay, so we can see water flowing out. Want to give it a second just to make sure that we do achieve steady state again. While we're doing that, we're going to see if there's any air bubbles in this outlet tube. If so, we're going to have to wait for those to dissipate before we can start our test. But so far, it's looking pretty good. Water is still coming out here. We're not overtopping the funnel. Water is coming out here, and I don't see any air bubbles. So we're ready to start the test. So what we're going to do is I'm going to, again, place this tube on the counter when we're ready to start. And I'm going to collect water into this graduated cylinder. I'm also going to use a stopwatch to time the duration that it takes to collect that volume of water. So I think we're good to go. So I'm going to start the stopwatch as soon as water starts collecting into the graduated cylinder. So ready, set, go. Okay. So I stopped the stopwatch as soon as I stopped collecting water into the graduated cylinder. So now we're going to reduce the flow of water a little bit, close the valves downstream then upstream, and now we can take our measurement. So first I'm going to look at the volume of water that we collected and record that on the data sheet. Then I'm going to record the time that it took to collect. And I'm also going to take the temperature of the water. We want to make sure that the thermometer isn't touching the glass of the graduated cylinder because it can skew the results. And then we're going to record that temperature onto our data sheet as well. So now we would typically run this test 2 more times. We would be shooting for about the same duration for each test, and we'd then be taking an average of the volumetric flow rate that we obtained from each of the 3 tests. But we always want to make sure that even though we're shooting for about the same amount of time for each test, that we always record the exact amount of time elapsed. And other than that, that's the end of our constant head test. Okay, so now we're ready to run our falling head permeability test. And first, we're just going to go over the equipment required. First and foremost, again, we have a permeameter. The permeameter itself is largely the same as the constant head permeameter. We just have a different setup attached to it. So here we have a burette filled with water. Water will flow out of the bottom of the tube and into the top of the permeameter. Just like before, the water will percolate through the soil specimen and it'll come out through this spout here. One difference we have is the soil specimen itself. Here we have a fine sand, whereas with the constant head test we had a little bit more of a coarser sand. So here we would expect the water to flow through the specimen a bit slower than before. We also have some deionized water. We have a stopwatch, and we have a thermometer, and we also have a meter stick as well. All right, so now we can get into the procedure. The first step that we're going to need to do is we're going to take our squirt bottle of deionized water and fill the burette all the way up to the top demarcation. So the way burettes are numbered is that the 0 line is all the way at the top, and then the numbers increase as you go down. So we're going to fill all the way to the top 0 milliliter demarcation, looking at the bottom of the meniscus as we do this. Okay, just like that. Then we're going to take our data sheet and we're going to record the initial burette reading, which is labeled as R1 on your data sheet. And since we just filled this to 0 milliliters, our initial burette reading is 0 milliliters. Okay, so that's our R1. Now we need to measure the initial difference in head, which on your data sheet is labeled as H1. So we are going to take our meter stick, put the bottom on the counter, and align it next to our burette. We're going to make a note of the height above the counter that the zero demarcation, or the top of the water level, is at. So we're going to make note of that. But now, since the spout doesn't quite go all the way down to the counter, we're also going to measure the distance of the spout above the counter, looking at the center of the spout for this. And we're going to take this value and subtract it from the initial value. And the difference between those two will give us the initial difference in total head for our first test. So let's record that on our data sheet. It is important to note that this is a falling head test. So this is just the initial head, which starts from here. And as the test goes, water is going to flow through the sample, and the water level in the burette is going to drop. So the head is going to be changing throughout the test. This also means that this initial difference in total head will change from one test to the next, because we're going to run this 3 times, just like with the constant head test. But anyways, we have just gathered R1 and H1, so you should have those filled in on your data sheet. And then we're ready to get started with the test. So I'm going to move the permeameter a little bit so that we can have the water drip into the sink. Unlike the constant head test, we're not actually going to be collecting this water because we're going to take our measurements using the burette. The burette is a lot thinner than any of our graduated cylinders, so we can get a much more precise reading of the volume that passed through the specimen. And this is important because with a finer sample, like we said before, water is going to flow through a bit slower, so this will just give us a more precise reading when we have less water actually moving through the soil. So we are going to take our stopwatch. As soon as I open the valves on the permeameter, we are going to start the stopwatch, and then when I close the valves, we're going to stop the stopwatch. All right, so here we go. We're going to open upstream and then downstream and start our stopwatch immediately. As this test is going, we'll be able to slowly see the water level in the burette drop as the water is flowing through the permeameter, and if you can see, dripping out of the spout over here. Okay, so I'm going to get ready to stop the test, and I'm going to hit the stop button on the stopwatch when I close the upstream valve. We're going to close downstream and then upstream, which is opposite of the way that we open the valves. Okay, so now we're going to go to our data sheet, and we can record the test duration, which is the value that we see on the stopwatch. And we're also going to record our R2, which is our final burette reading for this test. So we are going to read this off of our burette. This is in milliliters. Okay, so an important note is now we would typically run this test 2 more times, but we're not going to go through the trouble of filling up the burette all the way back to the zero demarcation. Instead, we are going to take this burette reading that we just recorded as R2, and we're going to use that as our R1 for test number 2. So we're going to use that same exact value. Similarly, we measured our H1 before the test, and that was the head between the zero demarcation and the spout of our permeameter. We're providing you a formula so that you can calculate your H2. We're not going to measure that again with a meter stick. However, we can use the difference in burette reading to calculate what the head is between the water level here and the spout here. So for test 1, that's going to be our H2, and we're also going to recycle that value as our H1 for test number 2. So we're doing a little bit of recycling values, so make sure that you keep all of that straight on your data sheet when moving from test 1 to 2 and test 2 to 3. The last thing that we need to do is to grab the air temperature of the room. So with the falling head test, this water isn't coming out of the faucet right now. It's been sitting out at room temperature, as has the deionized water that we're filling it with. So we can make the assumption that the water temperature for this test is the same as the air temperature. So we're just going to hold the thermometer, make sure that we're not touching the bottom with our hand. So we make sure we're measuring air temperature and not our body temperature. And then we can record this on our data sheet as the temperature. Okay, and then once you've done that, we are all done with the falling head permeameter test.